Today we are going to be looking at some properties of series, or more specifically, properties of summation notation. Okay, so remember that the summation notation is this. And in this section, we'll be going through some of the properties in relation to this summation notation that will help us simplify calculations a lot. So the first property is that if we have a summation, let's say from I equals m, I don't want to say 1 here because it also works for numbers other than 1. And let's say we have two different things being added in here. And these could or could not be in terms of I. So I'm just going to use x of I plus or minus y sub I. So I'm just using the subscript I because the x and y can be in terms of I or it may not be in terms of I. Okay, and this is going to equal, basically think of the summation sign as being distributed to each of the terms inside. So that's going to equal the summation from I equals m to n of x sub I plus or minus the summation of I equals m to n of y sub I. I think once I go over some of the examples concerning this, it's going to be much simpler to understand this. But for now, I'm just writing down the properties. So this is the distributive property. The distributive property. And we have one more property. If we have the summation n, and let's say we have a constant c being multiplied to something in relation to I here, then we can factor out the c like this. So it's kind of similar to polynomials. We can have the c come outside here, some x of y. The reason we do this is because we can not think about c. We can pull the c out, just work with the summation first, work with this part first, and then worry about the c after that. Okay, so let's do a few examples in relation to this to see how this will help us. So let's say we have a summation from I equals 1 to 10 of 2i squared plus 3i minus 4. Whoa. Okay, so basically this means we're adding from when I equals 1. Okay, so roughly speaking, when I equals 1, we have going to be 2 times 1 squared plus 3 times 1 plus 4. Okay, this is when I equals 1. Plus, when I equals 2, it's going to be 2 times 2 squared plus 3 times 2. And you can see already that this is going to be a tedious process if we don't have the properties that we talked about in the beginning. But with these properties, this calculation becomes much more easier. So instead of having to do this, we can use those properties. So we have 3 different terms here, which means we can use the distributive property. We can use the distributive property here to kind of distribute the summation to each of the terms inside. Okay, so now that is going to equal summation from I equals 1 to 10 of 2i squared plus the summation from I equals 1 to 10 of 3i minus summation of I equals 1 to 10 of 4. Okay, so now let's focus on each of these individually. Let's focus on this part first here. Now, we have a constant here. We have a 2 here. And according to this property, we can factor out the 2 to the outside. Okay, so basically we're left with 2 times the summation from I equals 1 to 10 of I squared, plus, we can do the same thing here. We can factor out the 3. Okay, 3 times the summation from I equals 1 to 10. Don't factor out the 4 here because there's no I here. So if you factor the 4 out, you can't really work with the summation. There's nothing to work with. There's nothing to work the summation with. So let's leave the 4 here for now. We have I left here, minus the summation from I equals 1 to 10, 4. Okay? And now we can focus on each of these individually as well. All right. Let's do our work up here. So this first part. This is, in fact, the sum of consecutive squares. Right? So we have a 2 in the front. We have the 2 in the front, and then inside the summation, if you remember the formula, it's the n times n plus 1 times 2n plus 1 divided by 6. This is the series of consecutive squares. So in this case, n is 10, right? N is 10. So we have 10 times 10 plus 1, which is 11, times 2n plus 1, which is 21, divided by 6. Okay, so this is our first summation here. All right, the first summation. Plus, second, we have a 3, right? This one. We have a 3, and then it's the summation from 1 to 10. And again, this is the consecutive integers. Oh, sorry, not the 3, just this part. It's the consecutive integers, right? It's going from 1 to 10. And n equals 10, so that's just 10 times 10 plus 1, which is 11, divided by 2. And then the last part, if you remember from the first section, this is the constant. We just have a constant here. There's no I. So for the constant term, it was just this constant times n. Right? N is 10 in this case. So that's just 4 times 10. All right. So now this, our summation problem has been simplified, if you want to call it simplified, has been simplified to this part. And we just need to simplify this to get our answer. And the first part here, in fact, we can cancel a whole lot of things here. So 2 and the 6 will cancel. The 6 will become 3. 3 and the 21 will cancel. That will become 7. And here, the 2 and the 10 can cancel. That will become 5. Okay, so we have 10 times 11 times 7. That's 770. Plus 3 times 5 times 11. That is 33 times 5, which is 145? No. 165. Minus 40. Okay, and then just simplifying. So 770 plus that is going to be 5. 9 minus 40. It's going to be 5. 9, 895 would be our answer. Okay, let's try one more example. It's a little bit of a different format. So let's do the summation from I equals 1 to 5 of 3 plus I minus 2 times 3. Okay, how can we calculate this part? Okay, so my tip is to simplify what's inside as much as possible. Okay, so let's simplify the inside first. This is going to be the summation from I equals 1 to 5 of, so let's distribute the 3 like this. So before you work with the summation, simplify what's inside the parentheses. We have 3 plus 3i minus 6, right? And then that's going to be 3i minus 3. Okay, so basically we have the summation of I equals 1 to 5 of 3i minus 3. Now, since we can't simplify inside the parentheses, we can start using the summation properties. Okay, so we can distribute the summation to each term. So we have summation of 1, or I equals 1 to 5 of 3i minus the summation of I equals 1 to 5 of 3. And again, the 3 can come outside. So we have 3 times the summation from I equals 1 to 5 of I minus summation of I equals 1 to 5 of 3. Now this part, again, is the summation or the series of consecutive integers. So remember that was n times n plus 1 over 2. And in this case, n is 5. So that's going to be 3 times 5 plus 1 is 6 over 2 minus, and here again we have a constant, no I, so that's just going to be the constant times the n, 3 times 5 here. So here this will cancel. We have 45 minus 15. Okay, so our answer is going to be 30. Okay, so you can use the properties of summation to simplify expressions and solve the problem.